I'm David Ortnow, a Senior Program Manager with the Mobile Developer Tools team, focused on Xamarin.Forms. In this video, I want to share with you some highlights of what we've been releasing over the last several months and what we're also releasing today for you to try out. So let's dive into some of the highlights. We've been focused a lot on quality, performance, and we also have some feature work for you. Quality and performance are key for our mobile applications and enabling you to have the best experience on your cross-platform apps. So .NET Standard 2.0 compatibility is now available, meaning you can take the Xamarin.Forms NuGet package, bring it into your projects of that type, and you're good to go. iOS 11 has introduced several new things for us, including safe layout and large titles, as well as a few other things, so that's something that we've come up to speed with. Compiled bindings, giving you the performance benefit, the type checking benefit of having that done for you. Accessibility improvements, surfacing those APIs so that you can make your apps more accessible. Merge dictionaries, which was a great community contribution, so you can merge multiple resource dictionaries in your application. And then we also have macOS and GDK previews now available for you to try out. So you can start taking your mobile applications, extending them to the desktop, and then modifying them to be more useful on a desktop application platform. And then today I want to dive more deeply into fast renderers, layout compression, and page embedding in native, which gives you not only performance benefits, but allows you to do much more with your Xamarin.Forms applications and to use your UI in many new ways. So let's jump in. Fast renderers. So if you're familiar with the Xamarin.Forms platform renderer architecture, what this means is that when you ask Xamarin.Forms for a button, on the native platform, you're going to get a button renderer and then that native element. So on Android, for example, it's an app compat button. But that means that two views are now being inflated on Android. And if we can do anything to avoid that, we absolutely want to, so that we can optimize that whole process. So with fast renderers, we've refactored the renderer architecture to allow us to do that. So now you just get the app compat button. But there have been some API changes, so what that means is that you need to opt into this to make sure it's right for your application. This works for button, image, and label, and you can try that today. In combination with this, in the spirit of reducing UI layers, we have introduced layout compression. So let's take, for example, a content page. In that content page, you have a stack layout. Within there, you have a grid, so now we're nesting our views. And within there, you have three labels. So that's 1, 2, 3, 4 layers of hierarchy below the page layer. And that's a lot of the UI tree that needs to be climbed up and down to make sure that everything's measured and laid out properly. And then to finish this off, we have a list view. So what if you didn't actually need those layout elements? You didn't need to create views for them. What could you do to remove them? What we've enabled is the ability for you to declare them as hidden. So then you can remove them, you don't need them anymore. So now that optimizes not only how many views are created, but it enables you to flatten the hierarchy of your views so that you don't need to go all the way up 4 or down 4 and measure all of that out for yourself. So let's take a look at how this works in some real applications. Okay, so here I have a simple profile screen, similar to something I've done for other applications, and so I felt it was a good example to show off fast renderers and layout compression. So this is an iPhone rendering of this screen. It's got plenty of views on it. You can see the layout is kind of interesting, and so it's a fairly good example. And I have the same thing running over here on Android. So what I want to do is then take a look at the inspector, which I have running right here, and I've attached it to my Android emulator. And if we look at this view and look at the hierarchy, on the left-hand side here, you see the hierarchy of all the views that get created. So like I was describing, button renderer, app compat button over on the left-hand side, you can see how that's creating a lot of views. And if we start to turn this, and you can see that's a lot of layers that we're generating. So first, let's enable fast renderers and see what that does for us. So in order to enable fast renderers, we come down into our Android project, which you can see over here on the side, and we come into the main activity where we're initializing forms. And just before we initialize forms, we can use the new setFlags API to pass in a string to opt into fast renderers, which we're calling experimental this time. As I described, the API has changed, and so it's not necessarily going to behave the same way as the initial renderers. We tried to do the best we could with that, but your mileage may vary. Try that out and see how your app behaves. All right, so we've enabled that. Let's rerun this application. And while that's running, we'll jump over to the inspector once it launches. All right, and you can see that my layout's the same, nothing has changed. So I'm getting all the same UI elements that I had before. We launch another inspector. And now if we inspect the hierarchy on the left-hand side, when it comes up, now you can see that we just get the button renderer. We just get the image renderer, just get the button renderer. We're not getting those additional layers there. And we're starting to, it's a little bit harder to see, but we're starting to flatten this UI out. All right, so now let's enable layout compression to flatten this out even further. In order to do that, let's take a look at some of the layout that I have here in my XAML. You see that I've got my content page and then I've got a stack layout. So anywhere that I have a layout that doesn't need to have a background color, doesn't need to accept gestures, I'm going to enable is headless. And so what is headless means is that I don't need to create a view for it. And to make this easy on myself, I can toggle this on and off. I've created a Boolean for use layout compression up in my app class. And so you can try this out easily yourself. So I'm going to enable that. Let's rerun. And then we'll take another look at that in the inspector. Now, what you want to notice is that it's still the same layout. We have not compromised our layout at all. And you can notice that I do have a layout at the top that's gray here. I wanted to call your attention to that. So I have an absolute layout here. Because it's using that gray background, I need that view to be created, so I can't make that one headless. If I do, it's going to disappear. I won't get my gray background. But the layout is the same. So let's open up the inspector, flip over to our cool view, and we can see that we have a much flatter layout now. We've done much better. So to count these all together, this comes from 130 UI elements initially. We were able to drop that all the way down to 70, which is above a 40% improvement in layouts and views that need to be created. The next thing I want to dive into is page embedding. So with Xamarin iOS, Android, and with UWP, you have the ability to share all your C# logic, but you're creating your UI 3 times over. So naturally, what you can do is you can use Xamarin.Forms to replace that whole UI layer. But what if you don't want to? What if you want to be able to use the iOS UI layer, the Android AXML files, you want to use natural native UWP XAML, but you want to sprinkle in some shared UI or some UI that Xamarin.Forms provides for you that you want. So what you can do now with page embedding is you can bring that into your native applications without declaring the entire UI Xamarin.Forms. So let's take a look at how that works, how you can enable that in your applications, and where you might be able to benefit from that. So here on my screen I have a weather application, a very basic looking weather application. And what I wanted to add to it was a shared UI to be able to view history. So this is iOS on the left hand here, or on this side of the screen, and you can see that I've got my, my forms, and I'm going to show you the code in just a second, and this is the exact same thing on Android. So we can load that up, and we can look at our 2 favorite cities, Seattle and St. Louis, and we get our weather. So let's go into the code, and I'll show you what we've got going on here. So this is my, and I'll go ahead and stop this so we get full screen. This is my XAML file. I have a shared weather app over here. So this is just forms. You see there's no app XAML. I'm not running a whole forms application. I just wanted to be able to share a little bit of XAML for a single page. So that's what I've got here, and then I've got a native Android application, native iOS, and a UWP application. These are not using forms, other than I'm going to embed this page in them. So that's what I'm embedding. That's the history view that you just saw. So in order to enable this and to utilize this on iOS, I can call my new history page, which is that page, that XAML page, and I just use the handy extension method, create view controller. This returns to me a view controller just as if I had made my own UI view controller, and I can now push this onto my platform navigation stack, just like I would push any other UI view controller. And again, binding is working, commands, eventing is working, all of that is working. Messaging center is being used to pass messages back and forth to the native platform, and I get my interactive view. Same thing is happening Over here on UWP, I can't run this, it's red squigglies because I'm running on a Mac, but it's the same thing happening. I have a history page, I can create the framework element, and now I can use that just as I would any other framework element or page that I would have created on UWP. And just to round it out, here is our Android code. So in my main activity, I have a method for show history. I do need to initialize forms before I call these things. So it's a one-time call that you can make in iOS, Android, UWP. It is optimized for this scenario, so it's not wiring up absolutely everything. Which is also benefiting us when you're running Xamarin.Forms, a speed boost. And here on Android, I want a fragment, so I grab my fragment and I create a fragment transaction, and I push it to my stack, to my view. So just like that, I've taken a Xamarin.Forms XAML page and I have embedded it in my native iOS, Android, and UWP applications. I get all the functionality I want, but I use it just where I want, and I don't have to use the entire Xamarin.Forms platform if I choose not to. So that's amazing. Let's cover some of the things that we currently support. So XAML compilation is supported, you get that performance benefit. You still get bindings, which is awesome. Messaging Center is available if you want to use it. Dependency service, if you don't already have an inversion of control container in your application, you want to use that, you can. And then of course, the primary thing you're going to be doing with page embedding is you're going to be creating those native UI view controllers, activity, fragment, framework elements, and then using them however you wish in your native applications. We think this is an amazing functionality for you. You can now blend your UI and use it however you want to, whether you start with a native Xamarin iOS, Android, or UWP code base and you're sprinkling in Xamarin.Forms, or maybe you have an existing Xamarin.Forms application and you've realized you're creating a lot of custom renderers and you want to start heading the other direction, but leveraging everything you've already done. You don't want to lose any of that great work. Now you can start to do all of that and benefit greatly. So what you can do today, absolutely download the releases, get the latest bits, try it out. And then you can learn even more if you head over to our blog where we feature a lot of these great pieces. And of course, as you're trying these things out, join us on the forums, talk to us, let us know how things are going, let me know how things are going, because that greatly informs our roadmap and where we're taking things. And then of course, continue your education on Xamarin University. A lot of great content there, a lot of great free content there. So head over there, watch the self-paced videos, you can join some live classes and enjoy that. With that, I'm closing, so thanks for watching.